Hello again. In this second video, we're going to continue with our last project. I will import a DVG file containing the geometry of a pipeline. I'll adjust the presentation of the line and automatically construct a ditch based on its geometry. I'll demonstrate how we can easily modify its path and compute the amount of soil that we'll have to remove in order to build the ditch. Importing a DVG file can be done in the following way. I go to Insert, choose Import, and choose App Layer Batch Import. I choose DVG and continue. I find my DVG file and click Open. I go to 2D and can see that my pipeline is in the drawing. To ease the work with the pipeline, I'll turn off viewing of the terrain layers and the orthophoto. We can see that the line is split into several smaller segments. For this project, I want to treat the pipe as a single line, so I start by joining the segments together. I use this function AppLayer join lines. To repeat a process, I simply press spacebar. There we go. I now select the pipe and use the function for automatically creating a road body. Roads and ditches are treated fairly similarly in Gemini. I type in a name of my road file and I call it pipe. This will have the file extension SFI. I can now choose to use a default set of variables for constructing the ditch. I'm going to use one of the Norwegian standards called grøft. Already now I can inspect my ditch in 3 dimensions. I can turn on the terrain and the orthophoto to see how it interacts with the terrain. We now have 2 lines, one describing the center line of the road or the ditch, and one describing the original geometry. The original geometry line is here in the pipeline application layer. It's the longest line. The other line is in what we call the command list. Actually, the line isn't here, but its road body is here. I can use this button to simply insert the center line of this road. We can see that the line definition is now already here. I will modify the presentation of the original line to make it look like a pipe with arbitrary geometric properties. To do that, I use an attribute called sfcode. I use some value, for instance 8201, which is a Norwegian standard for water pipes. I now go to the app layer list. I double click on the application layer containing the pipeline, and I use symbols to make a rule. This rule should say that for each SF code, or for each line with SF code containing 8201, I'm going to add a new presentation rule. These lines are supposed to be treated as pipes. The diameter of the pipe is arbitrarily chosen to be 1 meter. The thickness is, for instance, 2 centimeters. And as a reference line, I can use the bottom outer. I will insert elbows to make the bends look better, for instance with 1 meter of radius. I click OK, OK, and OK. Now we can see that the original ditch is too narrow for the pipe to fit in. We can see that the pipe comes out of the ditch because the default ditch settings are too narrow. We can now modify these settings. I do this by entering the cross sections of this ditch. I go to a random profile number and can see that my pipe is coming out of the ditch. To broaden the ditch, I go to the SFI properties. I go to surface generator parameters and I alter a couple of values here. From the center line, I go from 25 centimeters to 50 centimeters on each side at the bottom. This should be more than enough to encompass all of the pipe. To see the changes, I select all the profiles and build surfaces. Now we can see that the ditch is more than broad enough. We can also see that the terrain is automatically imported from the terrain strata containing the laser point cloud. I go back to 3D and should immediately see the ditch getting broader. The next step is to calculate the masses needed to be removed for building this ditch. I select the ditch, go back to cross sections. I can choose to generate new ones, or I can just look at the existing sections. I'm going to use a default mass type. I can find it under the same property dialog box. I choose to import a default one, and I use this first one. I now click this button to calculate all the masses in all the profiles. I can click this button to draw the results. These results can be exported to Excel. I can even go back to 2 or 3-dimensional viewing of the project and display the masses here that have been created. We can now see the amount of soil removal needed in each section. The last step of this demo will be to alter the path of the pipeline. This can be done in the following way. Let me just remove the viewing of these masses, as they obviously are going to change as the path is going to change. This pipeline now consists of 2 lines. One of the lines is the presentation line, or the original line that came from the DVG. The other line is what we call a command line, being the center line of the road project. By using a function called grips, I can take an arbitrary point in the line. I can also insert more points if needed, and I can remove them or move them around. I'm going to place this center point somewhere randomly. The next step is to build the ditch again. I choose automatic road building, and I will have to choose a new template for the ditch. I could have chosen the same template as I used the first time, but then I would lose the information about the broadening of the ditch that I've created. I choose to look for an SFI file containing templates in the current project, and I choose the already existing pipe file. In this way, I will keep the ditch parameters. I can now generate new cross sections to see the change immediately. I can even calculate the masses simply by clicking this button, and then choose to show the masses again. If we go back to 2D viewing of this, I can see that the ditch has changed, but the line hasn't. I also need to move the line containing the presentation rules of the pipe. I use the same function and simply snap it on this corner point. That was it. Now the ditch has moved, and the pipe with it.